Okay, so yesterday we took notes on potential energy, kinetic energy, speed. We learned how to use the speed formula tool, right? Where you cover up the unknown and then you do what the formula, the tool tells you to do. Okay? Today we're just going to take a few more notes on relationships, which hits content objectives 2 and 3. Okay? So, relationships. We're just adding on to those notes that we started yesterday. All right, now when I say relationships, okay, I'm not talking like who's dating who and who likes who, right? Not that kind of relationships. We're talking about math and science relationships. Okay? What that means is when you have two variables and you mess with one of those variables, what happens to the other variable? That's what a relationship is between two variables. If I increase one, what happens to the other one? That kind of thing. Okay? So the first relationship that we talked about with activity 3 was speed versus kinetic energy. Those were our two variables, and we learned when we mess with one, what does the other one do? Okay? What is the relationship between speed and kinetic energy? What's the relationship? In other words, when I do something to one, what happens to the other one? Yeah?
When you go faster, you have more kinetic.
Exactly. When I increase my speed, what happens to my kinetic energy? It increases too. So when speed increases, kinetic energy increases. This is called a direct relationship, when they both go the same way. Okay? You can write this in symbols. We're studying physics right now. Physics is a combination of science and math, and we use the same symbols. Okay, so increase is just used with an arrow. So if you increase your speed, speed is a little s, what happens to your kinetic energy? We just said it. Increases, right? So your kinetic energy increases. Kinetic energy is big K, big E. Or we could flip this, couldn't we? We could. If we decrease our speed, what happens to our kinetic energy? You decrease kinetic energy. They both go, the direction of the arrows go the same way. It's called a direct relationship. When one goes up, the other goes up, or when one goes down, the other goes down. They're going the same direction. Okay? You will get into some more relationships in the future where when one goes up, the other one goes down. That's called an indirect or an inverse relationship. So it's a different kind. All right, second relationship we talked about was what we did today. Mass versus kinetic energy. What did your lab prove to you today? How? More mass means kinetic energy, right? And how do you know that? How do you know that adding more mass increases the kinetic energy? Because your block went farther. If your block went the same distance, no matter how much mass you put in the cart, would that mean mass and kinetic energy have a relationship? No, but it did, okay? Did everybody find that the more mass they put in, the farther the block went? There's your answer, okay? So same thing. When mass increases, kinetic energy also increases. So if we did this with symbols, arrows, when mass goes up, mass is a lowercase m, by the way. That's a symbol. It's the same as meters, so that can get confusing. KE is the same. Or we could flip it, right? If your mass decreases, your kinetic energy also decreases. So now that we know that speed and mass both have relationships with kinetic energy, our next content objective will be to figure out which one affects kinetic energy the most, speed or mass. And that is going to make a difference in a car crash, isn't it? If you're in a car crash, is it your speed that affects your accident the more? Or is it the mass that affects the accident more? And we'll find that out in CO4.